Some equations have no solutions, and some equations have an infinite number of solutions. When it has no solution, that means there is no value you can find to plug in for the variable that will make the equation true. When there are infinite solutions, that means any number you plug in for the variable will make the equation true. So there are a total of 3 different kinds of equations. A conditional equation has one or some. It has a finite number of solutions. An identity is an equation that has an infinite number of solutions. So an example shows that x plus 16 equals x plus 8 plus 8. Any value you plug in for x will work, will produce the same, a true statement there. So go ahead and try plugging in a couple of different numbers. Okay, in the next situation, a contradiction has no solutions. So in the example shown, x plus 9 equals x minus 7, there's no value you can plug in for x that will show you a true statement. So if you manipulate the equations, try to solve the equations, and they cancel out, all the variables cancel out, so you are left with a true equation like 4 equals 4 or 0 equals 0, then there are infinitely many solutions. The solution set has brackets, and inside the brackets is all real numbers. But if the variables cancel out and you're left with a false equation like 2 equals negative 17, well, think of it that doesn't make any sense. So that equation has no solutions, and the solution set is called the null set. And the null set is written as a 0 with a slash through it, and notice there are no brackets. On the top of page 5 are 2 problems. Then let's solve them and see examples of the different kinds of equations. We've been solving problems that have at least one solution, and so those are called conditional equations. Now we're going to solve for different kinds of equations. In the first one, we use the distributive property, and we get 8n plus 6 times 4 is 24 equals 6n plus 24 plus 2n, and all I did was distribute the 4. 4 times 2 is 8n, 4 times 6 is 24. On the right, 2 times 3 is 6n, 2 times 12 is 24. And now we combine like terms on the right. And if you look right here, you see that you have the same thing on both sides of the equation. You can stop right now and say that this is an identity because they're identical on both sides of the equation. And if it's an identity, the solution set is all real numbers. Or you can go ahead and try to get the variables on one side of the equation, but you'll see that the variables go away and you're left with 24 equal to 24, and that's a true statement. So you can write all real numbers. Okay, you go ahead and solve the next one and describe what kind of an equation it is. I'm going to write out the solution now. So you can see this equation is false because you have negative 4 equals negative 19. So that is a contradiction, and your solution is the null set. Our next challenge is fun, and that is translating phrases into algebraic expressions. Now don't freak out because it's a word problem. Word problems are actually the closest we have to real-world situations. Okay, in this problem you have two numbers have a sum of 32, so that means they add together to get 32. If one of the numbers is represented by C, represent an expression for the other number. Okay, so what we know is one of the numbers C plus the other number equals 32. Well, let's just go ahead and write what I just said. C plus other number equals 32. You're supposed to write an expression for the other number. So essentially, let's get the other number by itself by subtracting C from both sides, and we get the other number equals 32 minus C. In the second example, it's similar. You have a product. The product means two things are being multiplied together. And when you multiply them, you get 8. X is one of the numbers, so X times something is 8. So you're told to write X times the other number because you don't know what it is yet. And so then we use our tools and divide both sides by X because our variable here is the other number, and we want to get the other number by itself. So the other number equals 8 over X. So practice that kind of problem using the problems on page 699. Okay, if you took 306, you are familiar with this. It is the process for solving an applied or word problem. Your first step is to read several times until you understand what you're given and what you need to find. Sometimes you need to draw a picture or draw a table to organize the information. Your second step is to assign a variable to represent what you don't know. And be sure to write down what the variable represents. Like if you're trying to find the cost of apples, write down X equals cost of apples. Third step, write an equation using the variable expressions. And the fourth is solve the equation. 5 is state the answer. There are 10 apples. And ask yourself, is that reasonable? And number 6 is check your work by plugging your answer back into your original equation. And at this point, as we are about to launch into word problems, most 308 students identify with this cartoon that you are missing the math gene, but don't believe it. Okay, step 1, read the problem. The product of 3 and a number decreased by 2 is 42. What is the number? So let's make sure we understand this problem. The product is a key word, a clue that tells us we're going to multiply something and it's going to equal, well, we don't know what it's going to equal, but part of it is going to be 3 times something else. So the product is 3 times something else. Then we read, and a number decreased by 2, so we don't know what a number is, so we're going to call that X. So a number is decreased by 2, that means 2 is subtracted from X is 42, so we do know the number. So we have 3 times a number decreased by 2, so we have to put parentheses around it, equals 42. So what is the number? Okay, there's our equation. 3 times, let me rewrite it so that the times, or I'll just erase that. That's a times, so I'm going to use a dot so it doesn't confuse us with the variable x. 3 times x minus 2. So there's our equation. We've assigned a variable, step 2. We've written an equation, step 3, and now we're going to solve. So we use the the distributive property to distribute that 3. We add 6 to both sides and get 3x equals 48, and then divide by 3, and we get x equals 16. So we're being asked, is 3 times some number equal to 42? And that number has to be decreased by 2. So to check our work, we plug it into the original equation. So we have 3 times 16 minus 2 should equal 42. That's 3 times 14 should equal 42, and it does. So we know that the missing number is 16. On page 17, at the top of the page, we have that a box contains a combined total of 68 pens and pencils. The box contains 16 more pens than pencils, so how many of each are in the box? So we know that the total is 68. We need to define a variable, so we're going to have x be the variable pencils. So we're going to say x equals pencils, so we won't forget at the end of the problem what our answer represents. And then we're told that the box contains 16 more pens than pencils, so the total is the number of pens is equal to 16 more than x. When you add the pens and pencils together, pens plus pencils, you get 68. So what we're saying is 68 total equals the number of pencils, which is x, plus the number of pens, which is x plus 16. So there's our equation. So now we look at the equation, and since everything's being added, we don't really need these parentheses. So we combine like terms. Let's start off in black and write a new column. 68 equals 2x plus 16. Subtract 16 from both sides, and we get 52 equals 2x. And then we divide by 2, and we get 26 equals x. So the number of pencils is 26. The number of pens is 26 plus 16, so that's equal to 42. And we check our work by saying, does the number of pencils plus the number of pens equal 68? So we want to know, does 26 plus 42 equals 68? And it does, so we know that this is correct. Okay, there are a lot of medical professional students in class, so this question will be right up your future alley. We have a mixture of acid and water that must be combined, and the total mixture will be 286 milliliters. If the mixture must contain 12 milliliters of water for every milliliter of acid, how many milliliters of water and how many milliliters of acid does it take to fill the beaker? So we are going to assign a variable. We're going to let x equal the acid, the milliliters of acid. So we know that x equals the acid, and when we multiply x by 12, because every milliliter of acid contains 12 milliliters of water, so we know that 12x equals the milliliters of water. And when we add those together, 12x plus x, we're told that we fill the beaker with 286 milliliters. So there's our equation. Simplify the left, and then divide both sides by 13, and you get x equals 22 milliliters. So the milliliters of acid is 22, and 12x, so let's go up here, 12x equals the milliliter of water. So 12 times 22 equals 264. So we're saying that there are 264 milliliters of water, and to check our work, we know that 22 plus 264 should equal 286, and it does. So there are 22 milliliters of acid and 264 milliliters of water. So go ahead and work the try it problems and get the hang of these word problems.